Okay, welcome back. This is Math 8 Unit 1, Scientific Notation. So in scientific notation, there's actually two forms that you're going to find, standard decimal form and scientific notation. And what this is going to be about is scientific notation, okay, is basically any number, okay, doesn't matter what it is, times 10 to a power. So right here, this is scientific notation. This also, 501 times 10 to the third power is scientific notation. 2.6 times 10 to the negative third power, that's scientific notation. 2,692 times 10 to the negative eighth power is also scientific notation. Now, what I need you to understand, though, is that there's something called correct scientific notation. Correct scientific notation is when you have a coefficient in the front that's between 1 and 10. So this number right here, that is correct. This number right here, 501 times 10 to the third, that is not in correct notation. Because this number right here, 501, is not a number between 1 and 10. This number right here, 2.6 times 10 to the negative third, is correct because it's a number between 1 and 10 times a 10 to a power. So that's great. But this one, 2,692 times 10 to the negative eighth, while it's scientific notation, it's not correct scientific notation. Okay? So that said, and that's what we had to talk about over the course of this unit, beginning of this unit. So standard decimal form, if I have something that's 7,120,000, okay, what I have to do is I have to place the decimal between the first and second significant digit. So in this case, I'd have to put the decimal right here. So scientific notation would be 7.12. You don't have to have the rest of the zeros. Okay, if there are any zeros in between these numbers, you have to keep it. Okay, you're not allowed to drop those. So you're going to write 7.12 times 10 to the, well, the number of decimal slides it would take to get to the end of this, or where the decimal is, would be a total of 1, 2, 3, 4, 5, 6 places. So that's what the power would be. This is a magnitude 6 problem, okay, otherwise known as the millions. This right here, 2,302, to show you that you don't just drop any zero, this would have to become 2.302 times 10. Now since this is a whole number, the decimal's at the end. If the decimal does not appear, you place it at the rear. Okay. So this caret here, where the decimal should be in scientific notation, would have to shift to the end to 3 places. So that's why this would be to the third power. Okay. You might get some other problems like this, 512.93. Well, in standard form, the decimal has to go between the first and second digit. So this will become 5.1293. You can only write the decimal one time here. I don't know what this camera's doing here. It's giving me problems again. Times 10. So what you do here is you'd have to move the decimal forward 2 places to get it to where it would have to be originally. Okay. Scientific notation is a way to write very large and very small numbers. So let's do some very small numbers right now. So 0.000063. Okay. In standard form, okay, that's a very small number. Okay. So anyways, scientific notation, the decimal goes between the first and second significant digit. In this case, it's 6 and 3. And guess what? We have to move this caret, where the decimal is going to be placed for scientific notation. We have to move it backwards 1, 2, 3, 4, 5. We'd have to move it back 5 places. Some people make the error by just counting the number of zeros. and putting that as a power. Remember, this power tells you how many places you need to slide the decimal to get back to the original location. Here's another one. Okay, 0.032005 would have to be, the decimal goes between the first two significant digits. We're not dropping these zeros because there's a 5 at the end. Place value is very important. So the decimal would go here, right? Between the first and second digit. Times 10 to the, this would have to move back 2 places. That's why it's a negative exponent. Backwards, 2 places. Okay. And that said, to go from scientific notation, you would just write 6⁻³ like this, and you'd have to move the decimal back 5 places, and then count the number of digits, or number of loops that actually don't have a number in it. You put zeros there. Okay, so there you go. The next thing we're going to talk about is adjusting the decimal. Okay. Sometimes what happens is you'll get scientific notation that's not in good form. Like, for example, 501 times 10 to the third. Okay, and what we have to do is, if we have to make this coefficient look smaller, we have to compensate by making this look larger. Okay, so the decimal here in 501 should be right at the end, but the decimal has to be here. So what we need to do is we need to move the decimal back 2 places. So it would become 5.01, okay, times 10 to the, so what happened here is you move the decimal back 2 places, right? That makes it decrease. So what we have to do is remember what we did, and we increase this by 2 because we moved this decimal 2 places. Okay, this is moving up, that's plus. If it's moving down, it's minus. So in this case, it'll become 5.01 times 10 to the 5th power. Okay. This also could be another way of looking at it. 501 times 10 to the 3rd power could be 501 1, 2, 3, because you slide the decimal that way. This would become 501,000, which would really become 5.01 times 10 to the 1, 2, 3, 4, 5. If you notice, these are the same exact answers. Let's not go around. Okay, so the next thing we need to do is add and subtract scientific notation. One of the things I taught my class is that when you have in 7th grade, you talked about solving equations and combining like terms and expressions. I like thinking of the terms combine, exactly alike terms, not just combine like terms. Exactly alike. So for example, if I had 7p plus 2p, there are 7p's adding plus 2p's adding, which is 9p. Okay. One thing I wouldn't be able to do is do 7p plus 2p plus 3p squared. This right here, 7p and 2p, are exactly alike p's. So you could add those together, but you cannot add these together because that's p and that's p squared. These are not exactly alike. Okay. Well, why am I talking about that? Well, when you add scientific notation, what's going to happen is you're going to get something like this: 7.1 times 10 to the 3rd plus 3.9 times 10 to the 3rd. You'll notice right here that these are both 10 to the 3rds. It's almost like saying you have 7.1 m plus 3.9 m. And since these are exactly alike, you could add these together and just go like this. 1 plus 9 is 10. Drop the decimal down. Carry that 1, 7, 8, 9, 10, 11. So this would be 11m. Or actually, in this case, it's 11.0. Instead of m, it's going to be that 10 to the third power. You see, we're only allowed to add exactly or subtract exactly alike terms. So since these are exactly alike, we're just allowed to add the coefficients together like this. Now we have a problem, because if you remember about scientific notation, this is not incorrect scientific notation. This is not correct. Okay. So what we need to do is make this into a number between 1 and 10. Move the decimal back that way. If you make this look smaller, you've got to make this look bigger. Since we move this one place, we're going to add one spot. So your correct scientific notation is going to look like this. 1.1, put the 0 there just to humor us, okay, times 10 to the fourth power. Okay, that's what that would be. Again, this is just a little side note to show you that we're really combining like terms. 10 to the third is really like this m, which is the same thing as this. So if we could add these together like that in 7th grade, in 8th grade with scientific notation, if these are the same thing, we can add those together. But we have to adjust the decimal to make this correct scientific notation. Okay. So what I'm going to do is I'm going to show you one when the powers are not the same. This is my wife vacuuming. I hope that's not too important. I feel like a schlub right now. Not helping, but I'm helping you guys out. So yay, points for Mr. Brown. She probably hates me right now. I'm just saying. Okay, so here's the thing. These aren't exactly the same, so we can't add these together. If I were to go like this and say 3.2 plus 5.1, no way. These are not the same thing. So how do you make them the same thing? Well, this has to bump up to become to the fifth power, so we're going to bump this up by 2. Okay. If you're going to add this by 2, guess what? You have to bring this down. So we have to bring this down by looking at making it look smaller. So 5.1 has to go backwards 2 places. So what you got here is that you'd have the 0.51 times 10 to the fifth plus 3.2 times 10 to the fifth. Notice now that we have the same exact last term. Okay, we have the same exact term. So what you do is you have to line the decimals up when you add and subtract. I put some zeros right there. That's going to become 1, 5, 2, 3. And notice that this is between 1 and 10. That's a good thing. And what did we add together? Oh yeah, we added 10 to the fifths types of numbers together. So that's 10 to the fifth power. That is correct scientific notation. So again, when you add like terms or subtract like terms, you can do that with the coefficients. When they're not the same, you have to bump it up to make it the same and compensate by making this decimal either larger or smaller. Okay, the next thing we're going to look at is multiplying and dividing scientific notation. This is the absolute last thing we're going to do, okay? Because I got to go. The vacuum's coming. I'm going to draw him another heart here because there we go. Like, let the camera soak that in. I love you, camera. It's like. So what you're going to do is go like this. What if you had 2 times 10 to the fifth times 3 times 10 to the sixth power? Well, what you would do here is you would actually multiply. Everything is multiplying together here. These parentheses right here, multiplication. Okay. You can regroup things together and just change the order if they're all being multiplied. And so you can go like this: 2 times 3 times 10 to the fifth times 10 to the sixth. 2 times 3, that's 6. 10 to the 5th times 10 to the 6th is 5 multiplying 10s and 6 multiplying 10s. This is scientific notation, but another way you can express it is here. 6 times 10 to the 11th power. Okay? If we did a similar problem over here, like 2.5 times 10 to the 3rd times 8 times 10 to the 2nd, you would actually go like this. Same thing, 2.5 times 8 and 10 to the 3rd times 10 to the 2nd. 8 times 2.5, you'll find out is actually 20. And 10 to the 3rd times 10 to the 2nd is 10 to the 5th. This is not scientific notation that correct anyways. So this has to become lower and that has to become higher. This has to move back 1 decimal place. This becomes lower by 1 place. This goes up by 1 exponent. So this becomes 2.0 times 10 to the 6th power. Okay. It's not going to help me either. Okay, let's see. Burning daylight. Burning daylight. Got to get more paper. Sorry, I ran out. Okay, last but not least, what we're going to talk about is division. Okay, so say you have 6 times 10 to the 3rd divided by 2 times 10 to the 2nd. Six divided by 2 here is 3. 10 to the 3rd would be this, divided by 10 to the 2nd. What happens is that these cancel and become 1s again, just like the exponents video I showed you. So what this would become is 3 times 10 to the 1st. Technically speaking, what you do is you just divide these powers, or you can reduce them. 6 divided by 2, 6 and 2. 2 can skip count into both of them, so you can reduce it like this. 3 over 1, which is just 3. 10 to the 3rd divided by 10 to the 2nd is 10 to the 3 minus 2. Technically, you could just do this, right? Which is 10 to the 0 power, which is just 10, which is this. So put these together, and you get this answer. Okay, so really with division, you do that. Okay, one thing you might see, very last thing, is so something like this. 4 times 10 to the 6th over 16 times 10 to the 8th. Okay, so this could be split into 2 fractions. Okay, what can skip count into 4 and 16? Well, 2 can, but also 4 can. So I'm going to take the larger number. 4 divided by 4 is 1. 16 divided by 4 is 4. Okay. Make that into an arrow. Some people make the mistake, I made it earlier, by making that equal. I'm going to put an arrow there because I'm actually going to do this next. So when you divide like bases, you subtract the powers. So you're going to get 1/4 times 10 to the negative 2nd power. 1/4 is actually 0.25 times 10 to the negative 2nd power. Okay, that's not correct scientific notation, so we'd have to bump this up and then bump this down. Now, some people get into really deep trouble here because they do something in their head. Now, because this is going down, we're going to subtract. Okay, this has to go over 1 spot that way, so we're going to subtract 1. This becomes 2.5 times, now look right here, -2 minus 1 is actually going back 2, then back 1. Or if I borrow $2 from you and then borrow another one, I've borrowed $3 total from you. So this would be 2.5 times 10 to the negative 3. Okay, thanks for watching this video series. Just going to have this right here. All right, I appreciate it. If this has helped you, please let me know. If there's something you'd like to see differently, let me know as well. All right, anyways, take care. Have a nice night.